Dear students, in previous lecture we have taken a overview of blockchain technology. Also we have discussed the syllabus of this subject and books we have to refer for preparing the subject. So in today's lecture we will go into the details of blockchain technology. Gradually we have to go into the insight of this blockchain technology. But before starting this session, we will quickly revise the previous session. In previous session we have studied the shortcomings of traditional transaction system. In traditional transaction system, the system is centralized system. System is controlled by the central authority, or you can say federal system, and if the central system fails, then overall system will fail. So in blockchain technology, the concept is that this system is decentralized system. Everyone has access to the system. It has the concept of shared ledger. The ledger is shared by all the participants, all the nodes. Every nodes can view the transactions in the ledger. In ledger, the data is stored in the form of blocks, and these blocks are linked. Each block is linked to the previous block by hash value. So we have the benefits of this blockchain technology. Blockchain technology is decentralized system. Every transaction needs to be validated. If the transaction is not validated by the nodes, then that transaction is discarded. Then it has low transaction fees, or we can say there is no transaction fee in the blockchain technology. We have studied the benefits of blockchain technology. It saves time, it has tight security, it has enhanced privacy, confidentiality of every participant is maintained in the blockchain technology. That also we have learned in the previous lecture. The transactions are immutable. That means once the transaction is recorded, that transaction cannot be changed, and after finalization of transaction, the block is added in the blockchain. So this we have studied. It has transparency. The system is open. So this part we have studied in the previous lecture. So in this session, first we have to understand the basic principle behind the blockchain technology. So for this we will take an example of chess game. In this game, Alice and Bob, these are the two players that want to play the game, and they will exchange the message between among them. The Alice will send a message to the Bob, and this message is nothing but a one move on the board of the chess. Then Bob will reply with message, and that will be the one move by the Bob in the on the board. So each of these messages is one move in the game. So what is the necessary condition to play the game? So we have concept. So to play the game, these players has to agree on the state of the board. If they don't agree on the state of the board, they cannot play a game. Both the players know the starting positions of the board, and both know the sequence of messages they exchange among them, and these messages is nothing but a one move on the board, and these messages make a transcript of the game. And when the game is over, we can reconstruct the state of the board by using this transcript. So in this the behind blockchain technology, there is a gaming theory. In gaming theory, if we agree on the history, then also we agree on the present state of the board. So this is the concept of gaming theory. So what is the relationship of this gaming theory with the blockchain? Blockchain, we have some distributed system, and in this blockchain we need that all the participants should should agree on the state of the system. If that participants don't agree, then the transaction is discarded and the block is not inserted in the blockchain. So if the participants agree on the initial state of the system, then they also agree on the history of the system. So does everyone agree on the current state of the system and also the previous state of the system. So we will take for this example of Bitcoin. Suppose I want to transfer 100 Bitcoins from my account. So first I should know the state of my system. I must have 100 Bitcoins in my account, and then I can transfer this Bitcoins to the receiver. So you need, in this you must have to know the current state of the system. So what the problem blockchain solve? In blockchain, every participant has to agree on the state of the system, and these participants don't trust on each other. But if they agree on the state of the system, if they agree on some transaction, then that transaction will be processed and that block will be inserted in the blockchain. So this blockchain technology is based on the principle of trust. So if participants don't trust on each other, if some participant denies the transaction, that transaction is discarded from the blockchain. So this is the basic principle behind the blockchain technology. So now we will go into the details. Trusted arbiter. Trusted arbiter is the centralized controller. This centralized controller is needed in the traditional transaction system. This centralized controller controls all the operations in the traditional banking systems or financial organization. If we had a trusted arbiter, there is no need of blockchain. In blockchain, there is no any centralized authority. The participants will initiate the transaction, and that transaction is validated by the other nodes or other participants. And if that transaction is validated by other participants, then that transaction will happen and that block is inserted in the blockchain. So we will take a example of payment system in banks. In banks, if we want to transfer the money, if we want to spend the money, then you have to send the message to the bank, and if bank permits transaction, then you can send money to the person whoever you want to send the money. So in disadvantage of this third party controller, or we can say centralized controller, if that centralized control system fails, then overall system will fail. So there is a single point of failure. If the trusted arbiter goes down for a week, the system stops working, and there is a concentration of power in centralized system. The centralized system has the censorship, and the owner, the operators of system will control the system, and without their permission we cannot do the transaction. So in blockchain technology, there is no centralized system. Participants trust on each other, and if they agree on the transaction, that transaction will happen. Otherwise, that transaction is discarded from the. So what is the block? So what does a blockchain buy us? Again, blockchain is a distributed system. In this blockchain system, the participants don't trust on each other or on any single entity. So whenever the transaction is initiated, that transaction needs to be validated by all the nodes, and if some node, some participant is not agree on the transaction, then that transaction may be discarded in the blockchain technology. So there is no need of trusted arbiter, or we can say centralized controller. in a blockchain system. So what is blockchain? Blockchain can be defined as a sequence of hash chain blocks that contains the information. You can see the figure. In this figure, the blocks are linked to each other. Each block contains the link to the previous block, and once the block is inserted into the blockchain, it is not possible to backdate this block, or it is not also possible to tamper the block. So the first block in the blockchain is called Genesis block. Blockchain is not Bitcoin, but technology behind the Bitcoin is blockchain. So there are several applications of blockchain, and Bitcoin is one of the application. The infrastructure, the technology behind the Bitcoin is blockchain. So blockchain is used for the secure transfer of items like money, property, contracts, etc. without requiring a third party like bank or governments. Once the data is recorded inside a blockchain, it is very difficult to change it. Once the block is inserted into the blockchain, it is difficult to change that block or to remove the block from the blockchain. So blockchain is not Bitcoin, but it is the technology behind the Bitcoin. Bitcoin is the digital token, and blockchain is the ledger which maintains the information about the tokens, the owner of the tokens. All this information is maintained by the shared ledger in the blockchain. So you cannot have Bitcoin without blockchain, but you can have blockchain without Bitcoin, because blockchain can be used for other applications also, in education, in healthcare, and there are different several applications of blockchain. So we have to learn the Bitcoin architecture. Bitcoin is a chain of blocks which contains information, and each block contains three type of values. Each block has data, hash, and hash of the previous block. So you can see the figure. Each block has the data, it has the hash value, and it has the hash value of the previous block. So these blocks are linked to each other by the hash. So the first block in the chain is called Genesis block, and each new block in the chain is linked to the previous block by hashes. So this concept of hash is very crucial. It is for security of the data and for maintaining the confidentiality of data. This hash, we have to learn about the hash, we have to understand this concept. So we will try to understand the hash. Each block has a hash. It can be understood as a fingerprint which is unique to each block. It identifies a block and all of its contents, and this hash is always unique. This hash value cannot be duplicated. It is like a fingerprint. We can say if we give data to the hash function will produce the fingerprint of that data. Fingerprint means the data is represented by some alternate way, and that alternate way is difficult to tamper, difficult to interpret that data. So once the block is created, any change in the inside the block will cause the change in the hash also. So we will learn more about the hash. Hash is a function. Is a type of mathematical function which turns data into a fingerprint of that data, called a hash. So this mathematical function will take a data as an input, and it will convert that data into the hash value. So it is like a formula. It takes the input and it turns the that data into the output of a fixed length, which represents the fingerprint of data. There are various types of hash functions. For example, SHA-256 is one of the hash function. There are other functions are also. By using that functions we can convert the input data into the hash. So when if we take the example of this SHA-256, if we want to convert a sentence hello from bits on blocks, if this input is given to the hash function, then you can see the fingerprint output of this input. So this output is difficult to interpret, and the good if the hash function is the property of the hash function is that that from the output we cannot construct the input. So there are two relevant properties of a good hash function. It is hard to back calculate the original data from the hash function. This property is because once the input data is converted into the hash value, and then if we can construct a original value from hash, that means any intruders or any person who wants to tamper the data, they can easily construct the original value from the output data, and this is not allowed. This is not a quality of the any hash function. Hash function should not allow to reconstruct the original data from the output data. If it allows, that means it will breach the security of the data. So if the input data changes, then hash will change in unpredictable way. So hashes are excellent mechanism to prevent tampering, to maintain the confidentiality of data. But nowadays computers become powerful, and because of high speed computers, hundreds or thousands of hashes can be tried, and the persons who try to tamper the data, they can calculate the input data from the hash value. So in a matter of few minutes, an attacker can tamper with a block, and then it can recalculate all the hashes of the other block to make the blockchain valid again. Because if the any block is modified, then that block will become invalid, because that block is not accepted by the other nodes and that transaction is denied. But if the attacker can calculate the data from the hash value, then attacker can modify the blockchain. They can insert the blocks, and this will create a problem in the blockchain technology. So to avoid this issue, blockchain uses one more mechanism, and that mechanism is called proof of work. So in coming lectures we will learn more about the proof of work. So how blockchain transaction works. In blockchain, if some person requests a transaction, the transaction could be involved. There may be several types of transaction, like cryptocurrency, like Bitcoin, or contracts, or records, or other information. So if some person initiates a transaction, requests a transaction, then that transaction is broadcasted to a P2P network with the help of nodes. That transaction is stored in the that we can say there is a concept of shared ledger, and this transaction, all the participants all can view the transaction, all the persons, all the nodes can view the transaction. And step 3, the network of nodes, these nodes will validate the transaction and the user status with the help of known algorithms. And once the transaction is validated by all the nodes, once the transaction is complete, the new block is then added to the existing blockchain, and in such a way that that block is permanently added in the blockchain. And once the block is added in the blockchain, that block cannot be altered, that block cannot be unchanged, that we have studied. So you can see the finger. First step is the transactions will be requested by a participant, that transaction is broadcasted, and then that transaction is validated. This is the third step, and after the transaction is validated, then that transaction is added to the blockchain. So today we have learned about the basics of blockchain technology, but we have to spend few more lectures on the basic concepts of this blockchain technology, because this technology is new technology. Just 10 years before this use of this technology started, first uses of Bitcoin, the white paper published by Satoshi. From that paper, the world came to know this Bitcoin, and from that for Bitcoin, this blockchain has provided the infrastructure. So we have to, in next session, we have to learn more about the blockchain, blocks, hashes. Then why do we need the blockchain? We have to learn about the distributed peer-to-peer network, proof of work, and smart contracts. The contracts are between the participants in the nodes, because whenever there is a business, this business happen with some conditions. So in this blockchain technology, this technical term, these are the new terms: proof of work, smart contracts. Then we have to learn type of blockchains, blockchain use cases, the real world use of the blockchain, that we have to learn, and why do we need blockchain, we will study in the previous lecture. So today we will wind up today's session. Thank you and goodbye.